Hello everybody, this is Yusuf Jibril, and today I'm gonna present this topic, which is talking about the silicene material. So, what is silicene? First of all, as we can all see here, this is the structure of the silicene. It's hexagonal. So, silicene is a two-dimensional allotropy of silicon, with a hexagonal honeycomb structure similar to that of graphene. Contrary of graphene, silicene is not flat, but has a periodical buckled topology. The coupling between layers in silicene is much stronger than in multi-layered graphene, and the oxidized form of silicene, so the 2D silica, has a very different chemical structure from graphene oxide. So let's talk a little bit about the silicine's history. Theorists had speculated about the existence and possible properties of freestanding silicene. Researchers first observed silicon structures that were suggestive of silicene in 2010. Using a scanning tunneling microscope, they studied self-assembled silicene nanorobots and silicene sheets deposited onto a silver crystal, AG110 and AG111, with atomic resolution. The images revealed hexagons in a honeycomb structure similar to that of graphene, which however were shown to originate from the silver surface, mimicking the hexagons. Density functional theory calculations showed that silicon atoms tend to form such honeycomb structure on silver, and adopt a slight curvature that makes a graphene-like configuration more likely. However, such a model has been invalidated for the SiAg110. The Ag surface displays a missing row reconstruction upon Si, so the silicon adsorption, and the honeycomb structure observed artifacts. This was followed in 2013 by the discovery of dumbbell reconstruction in silicene, which explains the formation mechanism of layered silicene and silicene on Ag. In 2015, a silicene field effect transistor was tested. That opens up a new opportunities for two-dimensional silicon for various fundamental science studies and electronic applications. So let's have a comparison now between the silicene and graphene. Graphene is often referred to as a wonder material. It has a superb electromobility and is so strong that it is possible to hold a single atomic sheet. Its density is around 1,000,000 times that of copper at room temperature. If silicene can be produced reliably, it could be even more exciting than graphene, since it will be more directly compatible with present silicon-based electronics. allowing its benefits to be more easily exploited. According to the European research team, silicene behaved in a similar way to graphene in terms of its electronic properties. They can move like particles without mass traveling through the lattice and the speed of light on continuous range of energy levels. And also in the shape. So it is similar to the graphene in the hexagonal shape, as we can see here in this picture. So it's very similar to it. It's hexagonal, but when we look at it as a plan, here the graphene is flat, but the silicene it have some buckles here. And this is a video that shows what is the difference between the graphene and the silicene in the shape. So let's see this video. So the graphene is the gray one, and the silicene is the kind of green. So it is, as we can see, it's hexagonal. Both of them are hexagonal, but when we look at it as a plan, look now, the graphene is flat, but here the silicene it has some buckles. So this video shows the difference between the silicene and the graphene in the shape. So let's talk now a little bit about the silicene's properties. Two-dimensional silicene is not completely planar like graphene. It consists of a hexagonal pattern of atoms, but in silicene the hexagonal rings includes a pocket ring distortion due to a chair configuration. Hence, this surface seems to have ordered ripples. Silicene can be converted to silicon by addition of hydrogen in a exothermic chemical reaction. This process could lead to application in hydrogen storage. As silicene is composed of silicon, it's compatible with present semiconductor manufacturing techniques. Its edges do not show oxygen reactivity, which suggests it will be stable enough to use in electronics. Some experiments show that silicene has an electronic structure which is analogous to that of graphene, which allow electrons to move through the material as though they had zero mass. Not all the evidence agrees with this, however, and the exact electronic properties have yet to be determined. So one of the applications of the silicene is the silicene transistors, and as we can see here in this picture, this is a transistor which use the silicene as a semiconductor to make and to manufacture this transistor. And in the conclusion, the study of silicene is still in its infancy. There needs to be a lot more clarity and agreement between the different research groups groups working on the material before silicene can be truly considered as a potential contender to take over silicon as the domination commercial semiconductor material. If its properties are proved, however, it may will prove to be another wonder material. Whether it will overtake graphene in popularity remains to be seen. And thank you for watching this video and this presentation. And if you have any question about this topic, you can contact me on my email, which is shown here on the screen. Thank you a lot, and stay safe. Goodbye.